This is video 17A for the Year 9 Mathematics course. In this video, we're going to be covering some example questions from the distance between 2 points under the topic of coordinate geometry. The 8 questions we will be going through are now displayed on the screen, so I recommend that you attempt these questions before watching the rest of this video. Question 1. Calculate the exact distance between 5,3 and 7,2. Alright, so the 2 points that we're working with here are 5,3 and 7,2. So, first thing that we can do here is classify these points as point 1 and point 2. So just for ease, I'm going to call this point here point 1 and this point here point 2. And so therefore, we can label each of these 4 coordinates as the following. x1, y1, x2, y2. Because we know that the distance between 2 points is given by the square root of x2 take x1 all squared plus y2 take y1 all squared. Now, 7 take 5 is 2, so we have 2 squared. 2 take 3 is -1, so we have -1 all squared. This here is now the square root of 4 plus 1, or in other words, the square root of 5 units. So the distance between these 2 points is root 5 units. Question 2. Calculate the exact distance between -1, 4 and 5, -6. So the 2 points that we're working with here are -1, 4 and 5, -6. So, first thing that we can do here is classify these points as point 1 and point 2. This one here I'm going to call point 1, and this one here I'm going to call point 2. And therefore, we can classify these 4 coordinates as the following. x1, y1, and x2, y2. Now, we know that the distance between 2 points is given by the square root of x2 take x1 all squared plus y2 take y1 all squared. Simplifying this, we get the square root. 5 take -1 is 6, so we have 6 squared, and then -6 take 4 is -10, so we have -10 squared. This here simplifies into the square root of 36 plus 100, or in other words, the square root of 136. We can separate this into the square root of 4 multiplied by the square root of 34, which is equivalent to 2 root 34 units. So the exact distance between these 2 points is 2 root 34 units. Question 3. Calculate the exact distance between -3, -8, and -1, 2. Alright, so here we're working with the points of -3, -8, and -1, 2. First thing that we can do here is classify this point as point 1 and this point as point 2, and therefore we can say the following. This one is x1, this one is y1, this here is x2, and this here is y2. Because we know that the distance between 2 points is given by the square root of x2 take x1 all squared plus y2 take y1 all squared. -1 take -3 is equal to 2, so we get 2 squared, and then 2 take -8 is 10, so we get 10 squared. This here simplifies into the square root of 4 plus 100, or in other words, the square root of 104. We can now split this up into the square root of 4 multiplied by the square root of 26, or in other words, 2 root 26 units. So the exact distance between these 2 points is 2 root 26 units. Question 4. The distance between 1k and 4,2 is 3 root 5 units. Find the value of k. Alright, so the 2 points that we're working with here are 1k and 4,2. First thing that we can do here is classify this point as point 1 and this point as point 2. Therefore, we can say that this is x1, this is y1, this is x2, and this is y2. Now, the reason why we've done this is because we know that the distance between the 2 points, which we are being told is 3 root 5 units, is equal to the square root of x2 take x1 all squared plus y2 take y1 all squared. Now we want to solve this equation for k. First thing that we're going to do here is we're going to take the square of both sides of the equation. On the left hand side, 3 root 5 all squared is equivalent to 45. Then on the right hand side, the square and the square root are going to cancel out. So now we have 4 take 1 all squared, which is 3 squared, and then 2 take k all squared. 3 squared is of course 9, so we now end up with 45 is equal to 9 plus 2 minus k all squared. Subtracting 9 from both sides, and we get 36 is equal to 2 minus k all squared. Now we can take the square root of both sides, because by taking the square root of the right hand side, the square is going to cancel, so we now are just left with 2 minus k. But then taking the square root of this thing here, we have to make sure that we're taking both the positive square root and the negative square root. So in other words, we get plus minus root 36. Of course, root 36 is equal to 6, so we end up with 2 take k is equal to plus minus 6. Rearranging this, and we get k is equal to 2 plus minus 6, or in other words, negative 4 or 8. So we actually have two solutions here for what k can be, given that the distance between these 2 points is 3 root 5. Either k can be equal to negative 4 or 8. Question 5. The distance between negative 310 and k negative 2 is 13 units. Find the value of k. Alright, so the 2 points that we're working with here are negative 310 and k negative 2. First thing I'm going to do here is classify this point as point 1 and this point as point 2. And therefore, we can say that this one is x1, this is y1, this is x2, and this is y2. Now, the reason why we've done this is because we know that the distance between 2 points, which we are being told is 13 units, is equal to the square root of x2 take x1 all squared plus y2 take y1 all squared. Now we want to try and solve this equation for k. First thing that we can do here is take the square of both sides. On the left hand side, 13 squared is 169. On the right hand side, the square and the square root are going to cancel out. So now we have k take negative 3 all squared, or in other words, k plus 3 all squared, plus negative 2 take 10 all squared, or in other words, negative 12 all squared. Simplifying this, and we get 169 is equal to k plus 3 all squared plus 144. Taking 144 from both sides of the equation, and we end up with k plus 3 all squared is equal to 25. Now, to get rid of this square on the left-hand side, we're going to take the square root of both sides. By taking the square root of the left-hand side, we're just left with k plus 3. But then with the right-hand side, when we take the square root of 25, we have to make sure to take both the positive square root and the negative square root. So this here now turns into plus minus root 25. And of course, root 25 is equal to 5, so we end up with k plus 3 is equal to plus minus 5. Then, rearranging this to get k by itself, we get k is equal to negative 3 plus minus 5, or in other words, negative 8 and positive 2. So in this particular situation, we actually have two different outcomes for what k can be, such that the distance between these 2 points is 13 units. It can either be negative 8 or positive 2. Question 6. Point P is equidistant from point Q and point R. Determine the coordinates of R. Alright, let's quickly label out all the information that we know about these 3 points. First things first, we know that Q has coordinates of negative 5, 2. P lies on the y-axis at 0.6, which means that P has coordinates of 0, 6, and R lies along the x-axis. Now, in this particular case here, let's just say that the x-coordinate for R is x. So in other words, the coordinates for R will be x, 0. And here, we're just trying to find out what this value of x is. Now, we are being told that point P is equidistant from point Q and point R. So in other words, the distance between P and Q is equal to the distance between P and R. So now what we can do is we can set up an equation for the distances between these pairs of points. Let's start off with point P and point Q. So the distance between P and Q is going to be equal to the square root of the difference in the x-coordinates, so in this case -5 and 0, so we'll do -5 take 0 all squared, plus the distance in the y-coordinates, so in this case we will do 2 minus 6 all squared, and this here is going to be equal to the distance between P and R, which we know will be equal to the square root of the difference in the x-coordinates, so that will be x take 0 and then square that, plus the difference in the y-coordinates, so that will be 0 take 6 all squared. Now, this is the equation that we're going to try and solve for x. First thing that we can do here is take the square of both sides to get rid of these square roots, because then this will cancel with this, and this will cancel with that. So now what are we left with? We're left with -5 take 0 all squared, plus 2 take 6 all squared, is equal to x take 0 all squared, plus 0 take 6 all squared. Let's now just go about simplifying all these brackets. -5 take 0 is -5. 2 take 6 is -4. X take 0 is just x. And then 0 take 6 is -6. So now we end up with 25 plus 16 is equal to x squared plus 36. Or in other words, 41 is equal to x squared plus 36, subtracting 36 from both sides, and we end up with x squared is equal to 5. Now, by taking the square root of both sides, we end up with x is equal to plus minus root 5. So in this particular case here, we've actually got two different outcomes. However, if we come back to the original diagram, we know that R lies on the positive x-axis, which means that from the diagram, x must be a positive number. And so therefore, the final solution is x is equal to the positive square root of 5. Now you have to be a bit careful here, however, because the question is very specifically asking us to determine the coordinates of R, not just the x-coordinate. However, we know that R has coordinates of x, 0, which therefore means that R has coordinates of root 5, 0. Question 7. A, -4, 2, B, 5, 4, and C, 2, -5 are the vertices of triangle ABC. Classify the triangle as equilateral, isosceles, or scalene. Alright, so what are the key differences between equilateral, isosceles, and scalene triangles? It is all about how many equal side lengths the triangle has. Equilateral triangles have 3 equal side lengths, isosceles triangles have 2 equal side lengths, and scalene triangles have 0 equal side lengths. Let's quickly lay out the points that we have. We have point A, which is -4, 2. We have point B, which is 5, 4. And then we have point C, which is 2, -5. Let's start off with the distance between A and B, which we know will be equal to the square root of the difference in the x-coordinates. So we have 5 and -4 all squared, plus the difference in the y-coordinates. So 4 and 2 all squared. Calculating everything inside the square root, and we end up with the square root of 85 units. Now let's do the distance between A and C, which again is equal to the square root of the difference of the x-coordinates, which in this case will be 2 and -4. So we have 2 take -4 all squared, plus the difference in the y-coordinates, so in this case, -5 and 2. all squared, which is equal to the square root of 85 units. And now finally, let's calculate the distance between point B and point C, which once again is equal to the square root of the difference in the x-coordinates, so 2 and 5, plus the difference in the y-coordinates, so -5 and 4, all squared, which is equal to the square root of 90 units. So, this particular triangle has vertices of length root 85 units, root 85 units, and root 90 units. Because only 2 of these side lengths are equal, we know therefore that this triangle must be an isosceles triangle. Question 8. A, 8, -2, B, 5, -6, and C, 1, -3 are the vertices of a triangle ABC. Show that this triangle is right-angled and determine where the right angle is. Alright, let's first of all jot down the 3 coordinates that we've got. So we've got point A, which is at 8, -2. We've got point B, which is at 5, -6. And we've got point C at 1, -3. Now, we first of all need to prove that these 3 vertices are for a right-angled triangle. Now, if we go back to our Pythagoras days, we know that for any right-angled triangle, the sum of the squares of the 2 smaller sides is equal to the square of the larger side, aka the hypotenuse. So that's what we're going to need to prove here, that the sum of the squares of the 2 shorter sides is equal to the square of the longer side. Or in other words, if we had this right angle triangle here, where this side length here is A, this one is B, and this one is C, then we know that A squared plus B squared is equal to C squared. And that's exactly what we need to prove here. So the first thing that we're going to need to do here is actually find out the 3 side lengths of triangle ABC, or in other words, we need to find out the distances between each 3 of these points. So let's start off with the distance between point A and point B, which will be equal to the square root of the difference in the x-coordinates, which are 5 and 8. We will square this, then we will add the difference of the y-coordinates, so -6 and -2, and we'll square this here as well. Calculating this, and we get root 25 units. Now let's calculate the distance between point A and point C. This here will once again be equal to the square root of the difference in the x-coordinates, so 1 and 8. We will square this, then we will add the difference of the y-coordinates, so -3 and -2, and we'll square this here as well. This here is equal to root 50 units. And then finally, let's calculate the distance between point B and point C, which will be equal to the square root of the difference in the x-coordinates, so 1 and 5. We'll square that. Then the difference in the y-coordinates, so -3 and -6. And we'll square this here as well. Calculating this gives us root 25 units. Now, the trick with this one here is the following. We realize that root 25 squared plus root 25 squared is equal to root 50 squared. Because then if you go about calculating this, we get 25 plus 25 is equal to 50, which we of course know is true. And so therefore, this root 25, we could say is distance AB, plus this root 25, which is this distance BC, is equal to the root 50 squared, or in other words, distance AC, all squared. And this is exactly what we needed to prove to show that this triangle must be right-angled, because we're saying that the sum of the squares of the 2 shorter sides is equal to the square of the longer side. So therefore, since Pythagoras' theorem is upheld, we know that this triangle must be right-angled. Now we need to determine where the right angle actually occurs. Because if I just quickly draw up a separate right angled triangle over here, we know that the longest of the 3 side lengths is this one here, so root 50, and the other two are root 25 units. And we know that the root 50 connects points A and C. So if I say that this one here is A, this one here is C, then this point here must be B, which therefore tells us that the right angle occurs at vertex B.